All right, let's do another one. We're gonna sketch the graph of the curve r equals 2 sine theta. So above we did 2 cos theta. Okay. Um, Here, instead of making a table of values, we're going to try to kind of feel our way through based on our knowledge of what 2 sine theta looks like in the Cartesian plane. Okay, so let's draw our axis. We're starting somewhere familiar. Here is our sine function, da da da. Okay, it goes up as high as 2, it goes down as low as -2. This is Cartesian, to be very clear, okay? Here we hit pi, here we hit 2 pi, so this is pi over 2, this is 3 pi over 2, 3 pi, 4 pi, 5 pi over 2, 7 pi over 2, and on and on and on, okay? Here we have now I'm my I'm going to be like where my r is equal to 2 sine theta, so my independent axis, my horizontal axis here is theta, and what's popping out is r, and I'm depicting this in the Cartesian coordinate system in order to draw the polar version of this, okay, the polar coordinates. Okay, so we're starting in this place that we're so comfortable with, right? This the Cartesian coordinate system, and then we're going to study how r and theta are related, all right, in order to figure out what's going on in the polar system. Okay, so let me draw my polar axis. All right, so let's start with a point. Here, this point, well, that is theta 0 and r is 0. Awesome. I just get to write it in there. Okay, how big do we get? Well, r gets as large as 2, right? And that happens at pi over 2. Okay, so that is this point here. Okay, and now we want to kind of like think about what's going on as we get there. What's happening in this portion of our curve? Well, if we think about it, like our value is increasing, right? See it going up like this. Like our r value is getting out and out and out and out and out big, but our theta value is also increasing. And so it's sweeping around out like so. Okay, that is this portion. Lovely. Okay, now let me draw, no, let's get the color that will show up. Let me draw this point. Okay, so my theta is back to 0. No, my theta is pi, my r is back to 0. And so I'm getting this point right back where I came from. So this is 2. Okay. Well, what's happening? Well, my r values are decreasing, right? My r values are decreasing, but my theta values are continuing to sweep out. Okay, and so we're kind of like going out like this. Oh, that's not very good. Okay, and so this part is this part. Okay, looking very nice. Okay, let's keep going. What's happening here? Well, now I have my r value is -2, and my theta value is 3 pi over 2. So 3 pi over 2, I'm like going all the way around to down here, right? My r value is negative, so I'm actually getting reflected back up. So this would be down here, but it turns into kind of like a ghost point. We're actually flipped across that polar across our pole. Okay, we're flipped across our pole and we're back there. Okay, and so while we kind of want to go out like this, sweeping down like this, right, as our going to make a line. Will it snap? It will. Excellent. This line is like sweeping, right? And so my angle is, this is here, it is at pi, a little pi and something, here's 3 pi over, 5 pi over 4, and here we are down at 3 pi over 4. But all my r values are negative as I'm going through here, right? All my r values are negative as I go through here. And so they're all being flung back to actually being traced over here again. Okay? And so what's actually happening, so we'll just kind of note r values are negative. Okay? So we would be here, but have to flip to the other side of the pole. Okay, and what happens? Well, we should actually get, this doesn't really look like much one, but this should be a perfect circle actually, okay? Centered at 0, 1. And I'm going to leave it to you to find the Cartesian equation for this curve following a process that we did similarly above. And then I'm going to just spend just a couple moments talking about this slide. So here are some more examples of polar curves. And it's very much worth your while spending some time trying to wrap your head around why these polar curves look this way. What are we doing? Well, I really, really urge you to, like, when we're doing this, I want you to think about interesting values of theta. Okay, so for our purposes, we're often more playing a matching game, but what's this theta? This is theta is 3 pi over 2, okay? What's this theta? Well, this theta here is equal to pi over 2, okay? And so think about those interesting values of theta. Think about the r value that pops out as you kind of sweep around our theta, and you're getting these interesting curves that emerge. All right, that is that's where I'm going to end this sort of introductory stuff, and now we're going to move on and take some derivatives.